In this video, we're going to talk about several good practices to follow when scaling your execution engines in Control Hub. In our last video, we learned that scaling refers to appropriately managing the size of the system running your engines. We also learned that resources, including CPU, RAM, storage allocation, and network I/O will all affect your ability to scale your engines. And we also asked you to remember that scaling is a continuous exercise within your organization. So now, let's look at 5 practical things you can do when scaling to make sure that your jobs run in the most efficient ways possible. First, we recommend that you regularly monitor your host system's resource usage. Better yet, it is a good practice to set up resource alerts on the host systems that run your engines. For self-managed deployments, these will be set up on the machine where you deploy the installation script. You can use the top command to monitor the CPU and memory used by your engines. These will display as Java processes. There are a wide variety of applications you can choose that can be configured on your server to alert you of resource allocation issues. For Control Hub managed deployments, you can monitor the performance within the host platform. Use the monitoring and alerting tools contained within these platforms to keep up with your engine performance. Second, set maximum resource thresholds on your engines to ensure you do not overtax your system. By default, your engine can allocate 80% available CPU and 100% available memory. You can edit your engine and select the Override Resource Thresholds box to enter different values for CPU, RAM, and even maximum number of running pipelines. A good practice is to enter lower numbers on this page to allow your engine to operate safely below the limits of your host system. Third, you can use Java options to change memory allocation and garbage collection in the JVM. In the Java configuration section of the Advanced Engine Configuration page, you can define memory allocation. By default, this is as a percentage of the host system's available memory. You can change this to an absolute value in order to better control memory usage. Additionally, you can use Java options to define garbage collection. For example, you may want to change from the default CMS to the G1GC collector. Fourth, make sure to use engine labels. This accomplishes 2 things. 1. Engine labels help you define and organize your engines. For example, you can use labels to define low versus high priority jobs. You can also use labels to define and group your lines of business. You can use them for many other applications that help you organize your engines and your jobs. And 2, labels are critical in implementing failover when needed. As a reminder, a job will only restart from a failed engine when the engine labels match the job labels. And remember that if a job has more than one label, then Control Hub can only schedule that job on a new engine with all of the same labels. Keeping a backup engine ready with all of the same labels as your job helps ensure you can run all of your pipelines at scale without interruption. Fifth, use subscriptions to alert you to potential problems with an engine. As a good practice, you should enable subscriptions for all production implementations. Engine status and job status changes are often the most useful events in alerting you immediately of issues with your pipelines. Make sure to select an action that will alert you quickly, so you can address potential problems with scaling before your pipelines fail. By applying these good practices, you can help ensure that your critical StreamSets pipelines can run at scale in your organization. Thanks for watching.